Hello everyone, this is John Gavin Fisher here, speaking for Team Tetris of the Fundamentals of Physics class of August 2014, Section 1. Our fine members are Jason Ardelian, Alexander Casado, Anthony Devanito, and Raz Herstig, all of which are being carefully guided by our fine instructor, Thomas Oakson. In this video, we plan to explain the concept of gravity. Now, little Newtons, put those apples away because today we're thinking with portals. We will be performing experiments today in the video game Portal to show examples of how gravity can be used in video games to solve puzzles. Before we get too far ahead of ourselves, let's talk about what we're working with here. Gravity is an attracting force that all mass exerts on each other. To make video games believable, game developers use gravity calculations similar to that of Earth, so we will be working with those same numbers. To solve for gravity on Earth, use 9.80665 for the acceleration towards the planet. You can round that out to about 9.8 meters per second squared. In the game Portal, you solve puzzles by using wormholes in space-time to change an object's placement and direction while conserving the object's momentum and acceleration. By using these changes in direction and placement, you can do something like put a portal at the top and bottom of a cliff, and jump off said cliff, then go through the portal changing that downward acceleration to sideways acceleration from the start of the cliff again. This can help you jump over a gap. Or you can make two portals right above and below each other, so you can have an endless falling cycle, which will allow you to reach terminal velocity without having to deal with your fear of heights. The game Portal is not played in a vacuum, so we will also have to solve for air resistance as well, which means that we can reach terminal velocity, which is the point where air resistance is pushing up on an object at the same force that the gravity is pulling down on that object, ceasing acceleration and leaving that object at a stable velocity until acted on by another force, for instance hitting the ground. Now you may be wondering, what happens without gravity? This state is called weightlessness. Weightlessness can technically be achieved without zero gravity. It is a state where an object simply does not have any support system. In Portal, we have examples of weightlessness where the environment can be used with certain tubes of zero gravity, so you can get from one place to another with all that pesky falling. By showing how these equations revolving around everyday experiences of falling into our planet, we can see how this can be twisted to make solving puzzles fun in a video game by having proper physics engines. Now, Portal is not the only game with a physics engine in it, but it is one that focuses on the physics being a key element of the gameplay. As time goes on, physics engines are becoming very essential in video games and even kind of standard. The physics engines being used to calculate for acceleration, velocity, gravity, and momentum are all increasingly common. Some games even calculate for air resistance, like in Portal, to solve for terminal velocity. Who knows? Maybe a property graphics physics engine could be implemented into Tetris.